Okay everyone, welcome to definite integration. Okay, C2 definite integration looks very similar to C1 integration, except we have these other little bits in here called limits, which we will talk about later. So we're going to integrate this curve, 3 plus 4x cubed minus 2 over x squared, and we're going to integrate it, the dx means, with respect to x. Okay, so before I integrate it, I'm going to get it into a form that I can actually integrate. So I'm going to move him up, minus 2x to the minus 2, and I'm going to integrate, we say between 6 and 4, but we'll explain that later, with respect to x. So let's start integrating. Arrows, 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 3 bracket bracket x plus 4 bracket bracket x minus 2 bracket bracket x. Okay, add 1 to the power gives me 1, and flip it. Add 1 to the power gives me 4, and flip it. Add 1 to the power gives me minus 1, and flip it. Okay, the minute I integrate, which is what I've done here, I mathematically put into a square bracket, and so that you guys can remember it goes into a square bracket, I found you a square dog. Well, sort of a square dog. All right, so square bracket, square dog. And the limits, the 6 and the 4 limits, the notation is that they move over here to the right-hand side. Okay, now notice that when I integrated, we call it integration, don't we? I have forgotten to add c, and I'm going to put him in very subtly because something's going to happen to the add c later. Okay, so let's neaten up these big square brackets. 3 times 1 over 1 is 3x, plus the 4's will cancel to give me x to the 4. The minus 2 and the minus 1 will make plus 2 x to the minus 1. And I'm going to shut my square bracket off, 6 and a 4, and we'll leave the plus c in there for the minute, but then I'll show you what happens to him. Okay, so what's going to happen with these limits? Okay, I'm going to show you. Imagine we had the curve of 3 plus 4x cubed minus 2 over x squared. So my original function. And what we're actually going to do is when we've got these limits here of 6 and 4, it's actually asking us to think about x equals 4 and x equals 6. And what we'll do when we do this direct integration is we will find the area between the curve, the x-axis, and the limits x equals 4 and x equals 6. So what we're actually going to do here is we're going to feed in the values x equals 6 and x equals 4 into my integrated function. So we're going to get 3 lots of 6. Now notice that I feed the one into the right first. So 3 lots of 6 plus 6 to the power of 4 plus 2 lots of 6 to the minus 1. And when they get fed in, now the brackets stay curly. Now what's actually happening is this. It's actually now giving me the area all the way up to 6. So if I evaluate that, I will get the area all the way up to 6. Now what I'm going to do is I'm going to feed the 4 into my integrated function. So it's going 3 lots of 4 plus 4 to the 4 plus 2 lots of 4 to the minus 1. And that's going into a square bracket. And therefore what I'm now doing is I am finding, when the 4 goes in, I'm finding this area up to 4. So the area that I want left, which is this area here, is found by doing the area all the way up to 6, subtracting the area all the way up to 4. And that's why there's a big subtraction sign in the middle of those two brackets. Now, I haven't forgotten about my plus c. He's here and he's here in there at the end. Okay, so we've got a calculator with our C2, so we don't have to panic. This first one, let's just rub him out. This first bracket is going to come to 18 plus 6 to the power of 4 is 1296, plus 6 to the minus 1 over 2 is a third. And we've still obviously got our little plus c in there. Minus the second bracket is going to come to 12 plus 256 plus 2 over 4, which is a half. And of course, we've still got our little plus c in. Okay, so if we have a look at these brackets, we're going to end up with This first bracket is not particularly nice, 3943 over 3, minus, obviously still got my little plus c in, minus this one here is coming out as 537 over 2, and I've still got my plus c. And then, of course, let's have a look what happens. 3943 over 3 minus 537 over 2 gives us a total of 6275 over 6. Now, I keep banging on, that's the answer. I keep banging on about this plus c, but have a look at this plus c, because actually if I've got this bracket and then I subtract this bracket, I'm actually going to cancel out the c's. So there is no c in the answer. No c in the answer. If you put a c in the answer, they will knock you a mark. So what you'll find is that quite a lot of people don't bother writing a plus c in the first place. All right, so you'll often find me when I've got limits, only when I've got limits, I sometimes don't bother putting a plus c in at all. Okay, here comes another one. So we're integrating between 2 and 1, 2 root x plus 3, bracket 2 root x plus 3. We can't integrate anything yet until we've neatened it up. Okay, so 2 root x times 2 root x is 4. 4 root x, 2 root x times 3 is 6 root x, 2 root x times 3 is 6 root x, and 3 times 3 is 9. So we're integrating between 2 and 1, and let's neaten it up. We're integrating between 2 and 1. Root x times root x is x, so that's 4x plus 12 root x, which I'm going to write as 12x to the half, plus 9. Okay, let's make that a bit smaller because I'm going to run out of some space. So that's just me neatening it up. And now I'm going to see if I can integrate it. So arrow, arrow, arrow. And in fact, I'm going to write him as 9x to the 0. So once I'm integrating 4 bracket bracket x plus 12 bracket bracket x plus 9 bracket bracket x. So add 1 to the power, that's a power of 1, so it's going to become 2, and flip it. Add 1 to the power makes me 3 over 2 and flip it. Add 1 to the power makes me 1 and flip it. And of course, I am going into square brackets. So I am thinking about my square dog. All right, there he is, my square dog into my square brackets. Okay, square brackets are going. Let's neaten him up. 4 times a half is 2x squared. Plus 12 divided by 3 is 4, and 4 times 2 gives me 8x to the 3 over 2 plus 9x to the 1. Finish off my square bracket, and in fact I've been sloppy. I should have then moved my limits over to the right. Okay, let's move him up a bit. I could probably move him up a bit. Can he go up a bit? Yes. Okay, right, let's start popping some numbers in. So the first thing we're going to do is we're going to feed the 2 in. We can imagine our graph. There's our graph. We've got the limits x equals 1 and x equals 2. So let's feed the 2 in. Curly bracket now. 2 lots of 2 squared plus 8 lots of 2 to the 3 over 2 plus 9 lots of 2. That's going to give me the area all the way up to here. Okay, so that's going to give me that bit. And then we're going to feed the 1 in. So let's feed the 1 in. 2 lots of 1 squared plus 8 lots of 1 to the 3 over 2 plus 9 lots of 1, close curly bracket. And of course, if I feed the 1 in, that's going to give me the area up to there. So the area that I want is found by me subtracting them. Okay, let's neaten these up. So 2 squared times 2 is 8, plus 2 to the 3 over 2 times 8. 2 to the 3 over 2 is 2 to the half, isn't it? 2 to the half cubed. 2 to the half is root 2. Root 2 cubed is root 2 times root 2 times root 2, which is, these will come together to give me 2 root 2. So that's 2 root 2 plus 18. Okay, so that's that bit. Minus, here comes my other bracket. 1 squared is 1 times 2 is 2. 1 to the power of 3 over 2, thank God, is 1, because 1 to the power of anything is 1, times 8 gives us plus 8 plus 9. Okay, so what have we got so far? 8 plus 18 is 26 plus 2 root 2 in the first one, minus, I think that's 19 from the second bracket. and therefore 26 plus 2 root 2 minus 19 gives us 7 plus 16 root 2. And that's an exact answer. So if they said exact, the word exact, I would leave it like that. But if they don't care and they want the decimal equivalent is 29.627417. So we could say, I don't know, 29.623 sig figs. And I really want you guys to be happy with this format of bracket minus bracket, all right? I want you to set it out next to each other by the side, then you won't go wrong. Guys, you probably want to pause the video, have a go and do this one yourself, and then I'll go through the answers, okay? So let's get it into a form we can actually not factorise, integrate. So we've got here 5x to the 0, haven't we, at the end? There he is. Okay, so arrow, arrow, arrow. So he's going 1 bracket, bracket x, plus 3 bracket, bracket x, plus 5 bracket, bracket x. So add 1 to the power gives me 4 and flip it. Add 1 to the power gives me 3 and flip it. Add 1 to the power and flip it. And we are integrating, so we're going into my square bracket. Okay, here he comes, square bracket, square dog. Okay, square bracket, square dog. And we are going to move the limits over. The limits are they -1 and -2? I can't see them under there. -1 and -3, aren't they? -1 and -3. Okay, so let's neaten this up. So we're going to end up with a quarter x to the 4 plus x to the 3 plus 5x to the 1 going into my square bracket with a -1 and a -3. Okay, so in goes my first one. My top one is going a -1. Curly bracket, quarter, -1 to the 4 plus -1 cubed plus 5 lots of -1. And here goes my -3. So curly bracket, quarter, -3 to the 4 plus -3 cubed plus 5 lots of, can I squeeze you in, -3? Big bracket in there, big bracket in there, and subtracting in the middle. Okay, let's neaten this up. -1 to the power of 4. Can you just do this in your head, guys, and just be careful because your calculator sometimes gets this wrong. But -1 to the power of 4 is +1, so that will come to a quarter. -1 cubed is -1, so -1, and 5 lots of -1 is -5. Okay, minus, here comes the next bit. -3 to the 4 is, it's 81, isn't it? It's a positive number, so that's 81 over 4. -3 cubed is -27, and 3 lots of -5 is -15. If we put those together, we've got a calculator. So my calculator is telling me -23 over 4, and my calculator is telling me -87 over 4. And therefore, it's coming to, on your calculator, an answer of 16. Did you get it right?